All right, so we're wrapping up the last part of this, the last section of this first chapter. Your quiz is when? Tuesday, okay? The first block on Tuesday. So we'll review on Monday, and then your quiz will be on Tuesday. I want to talk really quickly about number 7. 7 is a population problem, which means your answer is what? It's a whole number. Why does it have to be a whole number?
Because you can't have half of
Yeah, you can't have half of a person, right? So it's 737.89 or something like that. 737.89. So then that rounds to what? Approximately 738 people. What should you round the first two to?
To the 100.
To the hundredths? Why? Not because it makes it easier, because it's money. It's money, so you go to 2 decimal places with money. It's not that this is wrong necessarily. It's just that if the question is asking how many people would it be, you don't want to say there's like 0.8 of a person, all right? Because that's not a thing. All right, so the last thing we're going to talk about is kind of a review of all the functions that we've talked about for the past year pretty much. So we've discussed linear functions, quadratic functions, and exponential functions. And if we're talking about the way their graphs look, how does a linear function look when you put it on a graph? It looks like a straight line, right? It's going at a constant rate and looks like a straight line. What does a quadratic look like? A parabola. So it looks like a, what letter would you say? A U, either opening up or opening down. It has a max or a minimum, and it goes forever in the other direction. What does an exponential function look like? It kind of curves, right? It does a curve. So if we're looking at this one, is this exponential growth or exponential decay? This is decay. Why? Because it's going down. But it creates a curve that looks almost like a slide, right? Or half of a U, I guess, if it's going up. So an exponential function is going to either go up in a curve or down in a curve. A parabola is going to go up and also down. And then a line or a linear function is going to go in a constant rate straight line. So if you have data and you're trying to figure out if something is linear, quadratic, or exponential, how would you graph it to find out? What would you do there? You've got your x's and your y's, and then what do you do with them? Plot them on the graph, and you look to see what? If you're trying to determine if it's linear, quadratic, or exponential, what would you look for? To see what it does, right? See what the picture does. So in this case, I'm starting at 0, 10. So that's up here. This one's not going to fit. So I'm going to pretend these are counting by tens. All right? So 0, 10. Then I've got 1, 20. 2, 40. And 3, 80. So what type of function do you think that is? It's definitely not linear. How do you know it's not linear? Because it's not constant. It definitely has a curve. Why is this exponential and not a parabola? Okay, it doesn't have the extra part. What if you just didn't graph enough points? How could you tell that this is an exponential function and not a quadratic? It curves. Yeah, it curves at the bottom. Brendan? You could try some other points to see. Yeah, so you could go negative and do some other points. Assume if they've given you these points that this is enough to tell. So if they've given you these 4 points and are saying identify if it's linear, quadratic, or exponential, assume that if they've given you those points, that's enough that you know. So if it doesn't make a U, you can assume that it would be exponential. You know that it's linear if it makes a straight line, so it has to be a constant rate of change. So then this would be an exponential function. Okay, so then what would I do here? What would I do here? Graph it, same thing. Okay, I'm going to count by tens again because I don't want to run out of space. So I'm going to start at 0, 32, so a little bit over 3. And then I'm going to go 5, 41. So if these are counting by tens, then I'm going to go halfway and go up to a little bit above 4. And then I'm going to go to 10, 50. And then 15, 59, which would be approaching 6. And then 20, 68. So what does this make? Linear. That's a linear function. Okay, that one's a linear function because it makes a what? Straight line. Makes a straight line. So when you're plotting these onto a coordinate plane, you're essentially just looking to see what the behavior of the graph is. And when we say behavior of the graph, what do you think I mean? What do you think of if I'm talking about behavior? Like if I say, your behavior was really great today, or your behavior was not so good today. What am I talking about though? What's positive or negative?
The way it's going.
The way that you acted, right? So if I say like, oh, your behavior was awesome today, then I mean the way you acted was really good, right? But if I say your behavior was not so good, that means the way you acted was not so good. So if we're talking about the behavior of a graph, we're basically just saying, what is it doing? What is the activity of the graph? And this graph is moving at a constantly increasing rate, so that would be a linear function. Okay, so try these two. I don't know what's easier. If it's easier to do them at your seats, I know those coordinate planes are really tiny on your actual slides, so I don't actually know what's easier for you, but you can decide. If you'd rather try them at your seats, that's fine. Just put your answers on your board. If you want to graph them on the board, if that's easier for you, that's fine too, okay? So whatever you want to do, but your answers, your two, is it linear, exponential, or quadratic, need to be up on the board. Go. Okay, so something with number 2 that's a little bit difficult is it's kind of hard to tell between linear and exponential when you graph it, especially if you're creating your own coordinate plane, because if you're not putting the numbers on there, sometimes you're liable to like make it look a little bit linear when it's exponential. So graphing is a good way to do it, but is it the most efficient way? Probably not. So what we're going to talk about now is how we can do it without graphing. So there's 2 different ways that we're going to talk about, and then the one that I'm going to go back and tell you which one I always use. Okay? So how can we determine if it's linear, quadratic, or exponential without graphing it at all?
You see if it's constant.
Yeah, you see what kind of change happens between the x's and the y's, right? So if it's linear, we talked about this a little bit. I mean, we talked about it a while ago, but we talked about it a little bit on Tuesday. If it's linear, what's going to happen between the x's and the y's? Yeah, there's going to be a constant change, which we call the difference in x's and y's. That means we're doing what kind of math?
Subtraction.
Or addition, okay? So this is always addition or subtraction. What about if it's quadratic? What about if it's quadratic? So there's a constant x and then a constant what in the y's? Constant second difference. Thanks, Guillermo. So constant second difference. And what is second difference again? The difference of the difference, right? So the difference of the difference. Again, this should be what kind of math? Addition or subtraction. All right, and then how can you tell if it's exponential? It should be multiplication and division where? In the x's or the y's? The y's. We only care about the y's. So instead of calling it a constant difference, we call it a constant, starts with an R.
Rate.
Almost. Ratio. So that's multiplication or division. Yes. So that means when I'm doing this, I don't really spend a whole lot of time in the x's because the y's are going to tell you a lot more information than the x's are. The x's you can just kind of glance at and see if it's constant. They should be constant for all of them. So is this constant? Yes. So it's going up by 100. That doesn't tell us anything between differentiating between the other ones. So I pretty much focus on just the y's. So looking over here at the y's, it's getting what?
Lower.
It's getting lower, which means it's either going to be
Addition or
subtraction or
Division.
division. It's going to be one of those two. So let's try subtraction first. How much do you subtract to go from 400 to 256? So how would you do that on your calculators?
400.
Yeah, just do 400 minus 256. 144?
Oh, yeah.
Yeah, it should be 144. Okay, and then how do you go from 256 to 144? Minus what? 112, did you say? 12? Okay, so I can keep going, but do I need to? No? Okay, I know right now, as of right now, it's not which one?
Linear.
It's not linear. All right, I do need to keep going to figure out if it's quadratic, though. So then how do I go from 144 to 64? Is it 80? So minus 80. So then what would I do to figure out if it's quadratic? Find the second difference. So if I'm going from negative 144 to negative 112, what am I doing?
Minus 32.
It's not minus 32, it's plus 32. And then as I'm going from 112 to 80, what am I doing?
Plus 32.
Plus 32. So this is a what? Quadratic, because it's got a constant second difference. So this would be a quadratic. All right, so this one is quadratic because it has a constant second difference. So again, do I care much about the x's? No, because for all of them, they pretty much should be constant. So I check the y's, and the first thing I do is I do the first difference to see if that's constant. If the first difference is constant, then which one is it? Linear. If it's not, then I check the second difference. If that's constant, then what is it? Quadratic. If it's neither of those, then what do I have to check?
Exponential.
Exponential? How would you check to see if it's exponential? I'm looking for it to divide it, right? But I don't divide 400 by 256. I do not minus. 256 divided by 400, then 144 divided by 256, and last but not least, 64 divided by 144. So you kind of go backwards to figure out your constant ratio. And if the constant ratio is the same, it's exponential. However, the only reason you need to check that is because sometimes they're going to be none. Like if you have to check all three because they're going to be none. Now, if you've already figured out that it's quadratic, it can't also be exponential. So you're done there. So you don't need to do the exponential part. Okay? All right. So let's try this one. So first of all, looking at it, again, I don't really care much about the x's. So I'm looking at the y's. What's the first difference here? Minus 3,000. All right, what about here? 2,550, I think, right? And then what about here? And again, how can you do this on a calculator? Just subtract them. So I'm doing 14,450 minus 12,282.50.
2,000 something.
2,000 something. I feel like I'm in the Stone Age. 2167.50. All right, so that's 2167.50. So is that linear? No. So then how do I figure out if it's quadratic? Second difference. Again, how do you do the second difference on a calculator? What do you mean by adding them?
You don't need to.
I don't need to? Why not?
All you gotta do is just see. Isn't it like plus 500, plus 450?
Is that plus 450?
Yes.
To go from negative 3,000 to negative 2550? How did you get that though?
Because when
I want a rule. You might just know it, but I want to know like what could you do on your calculator to get it?
negative to
It's getting closer to zero, right? So it's definitely plus. Like I agree with that. But how could you get that number on your calculator? What would you do with them?
add them.
If I add these two together, that's going to end up giving me like 5,550. So I don't want to add them. I want to subtract them. So I want to subtract them. Just ignore the signs for right now. How would I go from 3,000 to 2,550? Just subtract them, which gives you 450. And then how do I get from here to here? Well, is it going to be 450? No, because that one already has like a 50 cents there. So it definitely can't be that. So it's not linear and it's not quadratic. So now I'm kind of starting from scratch a little bit. But again, exponential, not super difficult because you can do it on your calculator. I just have to do like 2 divided by 1. So this one divided by this one. So 17,000 divided by 20,000, which gives you what? So go ahead and someone do that on their calculator for us. 0.85. And then I want to do 14,450 divided by 1,700. So we just kind of work backwards. So 14,450 divided by 17,000 gives us 0.85. So do I really need to keep going or can I assume here? I'm going to assume. Okay, let's keep going. 12,282.5 divided by 14,450. All right, 0.85. So this is what type of function? Exponential. It's honestly up to you where you want to start. If you want to do the subtraction first or if you want to do the division first, it doesn't matter. I usually look for exponential functions first just because I think division is easier, so I like to do that one first. Okay? The important thing to remember is which way do you divide it? Like bottom up. So this one divided by the first one, the third one divided by the second one, and the fourth one divided by the third one. Okay, so exponential function. All right, so those are our 3 types. The other way to recognize it is if I give you a function table and you can turn it into an equation, what's going to be my difference? A linear function will have what exponents? Linear will have a constant. There will be no exponents, right? Okay, what about exponential? It will have exponential.
Second difference.
The variable in the exponent spot. And what about a quadratic? Quadratic will always be squared. Okay, so you can recognize it based on the equation. Now that's going to require, if I just give you a table, that you write an equation. So we're going to do this one. I will tell you right now, this is not what I ever do. Okay, it's good to be able to write an equation. I always do what we just did. I always do like the second difference or the constant ratio. Okay, so I'm looking at this. Let's consider this my x and this my y. So what would I have to do here, do you think, to get from x to y? If I'm trying to figure out the rule of this function. So let's take a look at an example one, just a little bit simpler one. If I said this is 1, what would you say is the equation here? Or what's the rule of this function? What do you do to x to get to y? Multiply by 3. So you'd say y equals 3 times x. And from there, you know it's what kind of function. It doesn't have an exponent, so it must be a linear function. So that's a linear function. Okay, so that's what we're talking about doing. We're talking about figuring out the rule here. But this rule is a little bit more complicated because these don't go in nice and evenly. So let's take a look at this. It's definitely going to be y equals because they all are. So what can I do to x to get to y? Well, what can I do to get from 0 to 375? Plus 375. I definitely can't multiply, right? I definitely can't multiply because anything times 0 is just 0. So there's definitely going to be a plus 375. I agree with that. All right? If there's a plus 375, now I look over here. Well, if I add 375 to 10, what does that give me?
It should be 385.
That would be 385 if I just did x plus 375. So it can't be just like x plus 375. I have to do something with x first. So I have to do something to x so that if I add 375 to it, like what would I have to do to 10? So that I add 375 and it gives me 325. What do you notice about 375 and 325? How much higher? 50 higher, right? So I need this to be not positive 50, but negative 50. Well, what can you do to 10 to turn it into negative 50? Times negative 5. So does that work over here? So try that on your calculator. Do 20 times negative 5 and then add 375 and see what you get. So 20 times negative 5 plus 375. That works? Okay, does it work for 30 also? So 30 times negative 5 plus 375 should also work. Yes, that works too? Okay, so that means this is the equation of this function, which means that it's what? Linear, quadratic, or exponential? Linear. It's definitely linear because it has no what? No exponent. Now, can you do it this way? Absolutely. Could we also have said minus 50, minus 50, minus 50, and then we would have known here it's also what? Linear because it's got a constant difference. So again, if I choose, I do it this way. I think figuring out the constant difference is easier than trying to figure out the equation. Is it a good skill to have to be able to write the equation from a table? Absolutely. What I want you guys to be able to do is write them from a table like this, where it's like simple or simple two-step ones. I don't really want to give you super complicated ones, nor do I really want you to be doing exponents right now. Okay, the point is I want you to be able to tell, how can you tell what functions they are and what the difference is. Okay, so any way you want to do these 5, you can do them any way you want. Again, which variable do we care about really? The x changes or the y changes? We really care about the y changes. Good. Okay, go do those 5. You're writing on the board for this one.